Okay, let us continue. So in the last class, we have discussed the method of solving the initial value problem by modified Euler method. So let us see one or two more examples in this case. Actually, modified Euler method means here we are modifying the answer obtained by using Euler's formula, and we get better solution. That means better answer, and that is obtained by Euler's formula. So again, you improve this using another formula. It's called modified formula. So we have to remember that modified Euler method, there it is equivalent to predictor character method. Predictor character method means first we are predicting solution using one formula, and another formula used to correct it or improve it. So we are using two formula in modified Euler method. One is to predict and the is to modify this. So how the solution given in this process is, first we find the initial problem, value problem may be given. Let it be dy by dx is equal to f of x comma y with the condition y of x naught is equal to y naught. Then if the answer in the nth iteration is known, let it be y sub xn. By knowing this, we can go for the next answer. That is the answer for y at n plus 1th stage. Its approximate value, it is given by this formula. The value at the stage x is equal to xn plus the slope of that curve. It is denoted by h into f of xn comma yn. So this is approximate value. Then we modify this using another formula. That is at the same stage, the solution is given by, that is y suffix n plus the average value of the slopes at two consecutive points. That is h by 2 into f of xn comma yn plus f of xn plus 1 comma yn plus 1. This is the formula you have seen. So modified formula means you have to use two formula that you have to remember. We shall continue with another example here. Suppose the question is asked like this: using modified Euler method, find the value of y at x equal to 1.2 in two steps. That's your not in two steps for this differential equation. Dy by dx is equal to 1 plus y by x with the condition y of 1 is equal to 2. So you have to note this condition. That is, we need the solution. The solution is given at x is equal to 1. At x is equal to 1, the value of y is 2. That is known. By knowing this value, you have to find the solution for y at x is equal to 1.2. If this step is not given in two steps, if it is not there, then 1 to 1.2, you can take h is equal to 0.2. But here they mentioned that in two steps means to get the solution at this step, we have to find the solution at the previous step. That means one more step is required. So 1 to 1.2 divide into two parts. So 1.2 minus 1 is 0.2 you get. Half of that is 0.1. So you have to take h is equal to 0.1, then you have to get the solution. So as usual, first let us see what are the given condition. Here given that x naught is equal to 1, y naught is equal to 2. That is all right first. X naught is 1, y naught is 2. Since we need the solution in two steps, you take h is equal to 0.1. If this step is not there, if this condition not given, then you can take h is equal to 0.2 only. But here, ask you to find the solution in two steps means you have to choose h is equal to 0.1. If h is 0.1, first you shall get the solution at x is equal to that x naught plus h. Let it be denoted by x1. So x1 is nothing but x naught plus h. That is x naught plus h means 1 plus 0.1. That's 1.1. At this point, you have to get the solution. And another step, add h to this. We shall call it as x2. x2 is nothing but x1 plus h. That's 1.2. So before getting the solution at 1.2, we need the solution at 1.1. So it is in two steps you have to get the solution. This is the meaning of this. So first given conditions, x naught is 1, y naught is 2. We are choosing h is equal to 0.1 because it is asked to find the solution in two steps. And f of xy means the right hand side of this differential equation. This f of x comma y is 1 plus y by x. There is a relation how the variables are connected. Now, problem is using modified Euler method you have to solve. So first predict the solution at the point x1 first. X1 is x0 plus h. So what is the predictor formula? The solution at that point is given by, let it be y1. The solution at x1 we denoted by y1, but put a star on the top that it is only approximate solution. So what is the Euler formula? Euler formula is solution at y1 is given by y0 plus h into f of x0 comma y0. That is y0 is here 2 plus h is 0.1 into f of x0 comma y0. x0 is 1 here, y0 is 2. This is f of x comma y, but how f of x comma y is related? That's 1 plus y by x. That means 1 plus y coordinate by x coordinate, we get is 2.3. This is the value of y1 by Euler's formula. But question is to use modified Euler formula. The meaning of use modified Euler formula means this answer obtained, you have to modify this. That means you have to improve this and you have to get the exact solution. This is only approximate solution. To get this, use this modified formula. So how to use this? So this formula is given by the value of y at x is equal to x1 is given by the modified formula is y1 is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 star. This y1 star is nothing but you obtain using Euler's formula. So using this you have to modify this. So write all these values. Y0 is known. What is y0? Y0 is here the same value. It's 2. So it is 2 plus h. H is written 0.1. So 0.1 by 2. F of x0 y0. It is f of x1 y1 star. But f of x comma y, how is defined? That must be known. F of x comma y is defined as, so this should know it is y0. It is h by 2. It is f of x comma y. F of x comma y is related by 1 plus y by x. That means 1 plus y coordinate by x coordinate plus it is f of x1 comma y1 star. X1 1 plus y by x. This is y 2.3. This is x1. You add this. So we get it is 2.304545. Using Euler formula, you got 2.3 something only, but using modified formula, you got this answer. But how to believe this answer, whether it's correct or not? To check it, better to use this formula once again. That means use the modified formula. If the answers are very close, then only we can stop the iteration process. Otherwise, you have to continue. So here I got y1 is equal to this much in the first iteration. That means when this formula, modified formula, used once. Once again, we shall use it. Using means what is the modified formula written? Y1 is equal to it is y0 plus h by 2 into f of x0 y0 plus f of x1 y1 star you write. This y1 star means there is always approximate answer. So this is y by x. So y only changes. So what you have to do is all this remains the same while using that modified formula once again. Only changes this value. This value is replaced by the new value obtained. So replace 2.3 by this new value. So that means once again using this modified formula, what happens? All this values remains the same. Only this y value here, because it is f of x0 y0. This is f of x and y1 star. How they define 1 plus y by x. So this is y. This value changes. So this is replaced by this new value. If add it, we get it is 2.304761. Here I got 2.304455. Here, very close to that. 3 digits are repeating after the decimal. So this is the answer correct to 3 decimal places. So you can stop the iteration. So this is the value of y at x is equal to x1. x1 means that point. So we can call it, that is 1.1. So the value of y at 1.1 is 2.304761. That we can accept. But the question asks you to find a solution at 1.2. So for that, next we shall see an approximate value for y at x is equal to 1.2. For that, first use Euler formula. That is approximate value for y2. y2 means value of y at 1.2. The formula for y2, it is y1. The general formula you have to remember, yn plus 1 is, it is yn plus h into f of xn comma yn. If it is 2, it's 1 less than that. So y1 plus h into f of x1 y1 is the approximate value. So it is y1 is here, the same value 2.304761, and h is remains the same 0.1. X1 is here 1.1, y1 is this value. So simplify this, all this values remains the same. F of xy is defined in this problem by, it is 1 plus y by x. That's the relation given in the problem, 1 plus y by x. So this is y by x. Simplify this, we get it is 2.614283. This is one approximate value for y2. Now use modified formula. How to use modified formula? That is this average slope you have to take. So the formula is y2 is equal to, that is y1 plus h by 2 into f of x1 comma y1 plus f of x2 comma y2 star. These values are written here. Y1 is the same value, h by 2, 0.1 by 2, f of x1 y1, this is x1, it is y1, all this remains the same. Only new value get here x2 1.2 and y2 star. Approximate value for y2 you got using Euler formula. Substitute. Now f of x comma y, how you define f of x comma y? It is 1 plus y by x. So it is 1 plus y by x. Here also f of x comma y defined by 1 plus y by x. Now simple calculation, using calculator simplify this, you may see that this value is y2 is equal to 2.61845. Here I return a star because this also I take it as approximate value, because the previous value using Euler formula you got it as y2 is equal to 2.614283. In one iteration, first iteration I got 61845. Two digits are repeating. So better to modify this answer once again. If you use this modified formula once again, modifying the once again using the modified formula for this value means only changes this value, because this is f of x0 y or x1 y1, it is f of x2 y2. This y value only changes, so this value replaced by the new value. All values remain the same. If you replace this, what you get, this 2.64283 replaced by 2.6184504. Sorry, this new value, right? 2.61845. Right. Two more digits also written. Actual value is 2.6184504. Okay, if we simplify, we may see that this answer is 2.618862. So here 3 digits are repeating. So we satisfy this answer and we believe that the solution for this problem at 1.2, it is 2.618862. So this is the solution for the differential equation at 1.2. Like that, when a problem is given to solve by modified method, we can find the solution. So one more example, it is to solve the differential equation dy by dx is equal to log of x plus y with the condition y of 1 is equal to 2.5314 at the point x is equal to 1.2 and 1.4 with the h is equal to 0.2. But here I'll solve at 1 point only, x equal to 1.2. At the next point, we can continue because the same process, we have done already 2 problems, same step you have to proceed. Only I write the solution at this point, at 1.2. Next, similarly, as you see in the previous problem, you can continue and get the solution at 1.4 also. So here, x0 is here 1 and y0 is here 2.5314. And ask you to take h is equal to 0.2. So everything is clear. And f of x comma y is log of x plus y. x0 is here 1 and y0 is this one. So what is x1? x1 is x0 plus this h. So x0 is here 1 plus 0.2. That is 1.2. That is x1. But we need solution at 1.4. That is taken as x2. x2 is equal to, again, 1.2 plus 0.2. That is 1.4. So at x1 and x2, we have to find the value of y, calling y1 and y2. So first step is same, identifying what is x0, y0 and h, that is not, and f of xy, the relation between the variable, that is log of x plus y. Here log of x plus y, you shall take base as 10 here. Otherwise, you can take base as E also. Usually, if the base is not given, you have to take the base as E here. So here it's not given, so you have to take base as E. If the base is mentioned, then only base 10 is taken. So in the calculator, when the base is not mentioned, understood that base is E. So in calculator, you have to press that LN button. If it is given base as 10, then in the calculator, you have to press LOG button. So LOG means log, LN also log in calculator. But when the base is E, it is mentioned that the calculator is written, that is LN. That button you have to press. Okay. First, you have to find the solution at 2 points. At x1, that is x0 plus h means 1.2. Another point at x2, that is x1 plus h, it is 1.4. So first, use Euler formula. The star represent an approximate value for y at x is equal to x1. The formula is y0 plus h into f of x0 y0. This is y0, which is written here, plus h is 0.2 into f of x0 y0. x0 is here, it is 1. So let's stick here. It is x0. x0 is here 1, and y0 is 2.5314. So it is 1 here, right? So if you substitute, again it is taken here 1.2. So correction will be there. This is not the correct answer because here it is 1.2 is mentioned. So it is not 1.2. This is x0. x0 is here 1. y0 is 2.5314. So this will be 1 plus this. So small change will be there. Instead of 2.6457, you may get 63 something will get because of this change. So that is y1 star. Then improve the answer by using modified formula. Modified formula is y0 plus h by 2. The slope plus the slope, add it. So this is f of x0 y0. Similar to the previous problem, only changes identify what is x0 y0 x1 y1 star. Substitute all these values, and you may see that this answer is 2.64469. There you got 2.6457, but because of this mistake you got it. Here also you won't get this much, but you may get very somewhat near answers. So if you want to improve, once again improve this method and get the good answer for this, right? Similarly, the solution you can obtain at the next point. So we are done to example earlier. So this just to get an idea, one more problem is done here. So this is called Euler's modified formula. So similarly, work out some more problems to get practice. I'll give these problems to you. Try to answer this. So write these 4 problems and try to answer all these problems using modified Euler method. So as I told, you have to use 2 formulae, one to predict the solution, another one to improve the solution. In the first problem, they ask you to find the solution at x is equal to 0.4 in 2 steps. Y of 0 is given 0. So x0 is 0, y0 is 0. In 2 steps means first you have to get the solution at x1, next at x2. So what is x1 here? That is 0 plus h. To reach from 0 to 0.4 in 2 steps, what must be the value of h? It must be half of that. That means 0.2. So take h is equal to 0.2 here, and first to get the solution at x1, that is x0 plus h means 0.2. First to get the solution at 0.2, that is x1. Next to get the solution at 0.2 plus 0.2, that is 0.4, that is at x2. So get the solution at x1 and x2 as is in the previous problem and see what is the solution for that. The relation is given is x plus modulus of square root of y. Why this symbol is written? So square root of 4 means there are 2 values, plus or minus. But I take only positive value. For that reason, this absolute value symbol is written. So suppose this 9 means don't take plus or minus 3, only 3 you can take. Similarly, here also the same type, relation is different. Here x plus magnitude of root of y. Here 2 plus magnitude of positive value of square root of xy. Similarly, these 3 problems, same type, right? And try to solve these 4 problems using Euler's modified method. I have copied these problems and try to answer. And this last question is taken from last year's exam question paper. The same problem asked in the last year's exam to find the solution by Euler's modified method. Here the given base is 10. So in the calculator, you have to press log button. If it is not mentioned, then you have to press the ln button to get the value of f of x comma y. Right. Now we shall go to another method of solving the initial value problem, which is called Runge Kutta method. Actually, Runge Kutta means two German mathematicians. They developed this formula. Actually, this formula developed by Euler modified method, and it is also called RK method. And there are different Runge Kutta methods. All are distinct by their order. Second order Runge Kutta method, third order Runge Kutta method, and fourth order Runge Kutta method. Like that, three methods are there. But in your syllabus, two methods are given. One is Runge Kutta method of order 3. Another one, Runge Kutta method of order 4. But what is Runge Kutta method? Let us see. This is nothing but Euler's modified formula itself. So we shall go to the previous slide once again. So we shall recall this Euler's formula. See, for example, we shall take this formula, right? This is the Euler's modified formula written usually. We shall take for y1. Okay. Oh. So here written the Euler modified formula here. This one, y1 is equal to y0 plus h by 2 into f of x0 y0 plus f of x1 y1 star. This is actually Euler's modified formula to improve the answer. Here, Runge and Kutta, what they have done is, instead of writing, they are given a symbol for this. They denoted this f of x0 y0 into h by k1 and this much into h by k2. So what this formula becomes, y1 is equal to y0 plus this h is taken inside. So 1 by 2 into h into f of x0 y0 to call it as k1. This one as h into this much is k2. So we get y0 is equal to 1 by 2 into k1 plus k2 again. And they called this one as RK method of order 2. So RK method of order 2 is nothing but only modified Euler method. But why that is important? Because Euler's RK method is important. The reason is that not they that copied this formula, they modified this formula. Actually, this is modified formula of Euler formula. Once again, they modified. Instead of using this iteration formula several times, Runge and Kutta, they modified this formula. And they written Runge Kutta method of order 3 and 4. So Runge Kutta method of order 4 is very famous because of this very fast answer. Instead of going on doing the iteration process, in first stage itself, we get the answer. So from where they obtain this answer means that is from basis Euler's formula. So we shall go to this. So that's RK method of order 2 is nothing but Euler modified method. So no need of writing this. Now in the syllabus, we shall see only Runge Kutta method of order 4 and Runge Kutta method of order 3. 3 also very slow process. So give much importance for Runge Kutta method of order 4. Order 2 is already seen. There is modified Euler method, right? So let us see what is Runge Kutta method of order 4. So when a differential equation of this type is given, consider an initial value problem, dv by dx is equal to f of x comma y with the initial condition y of x0 is equal to y0. Usually they give the differential equation like this. Suppose that I need the solution for this differential equation at x is equal to x0 plus h, let it be denoted by x1. At this point, I need the solution. Then the solution at this point, by knowing the solution at x0, is given by this simple formula. y1 is equal to y0 plus 1 by 6 into k1 plus 2 times k2 plus k3 plus k4. This formula is called Runge Kutta method of order 4. Runge Kutta method of order 2 means this k1 plus k2 only divided by 1 by 2. That is modified method itself. But that is modified once again, and you got this answer. And sorry, this formula that is called RK method of order 4. So what is this k1? K1 is nothing but, as I see in Euler's method, that is the slope of the curve at the point x0 y0. So that is h into f of x0 comma y0. And what is K2? The slope is taken very near to that another point. That is h into f of, that is x naught plus, for this x coordinate, add half of this h. That is x naught plus h by 2. And for y naught, you add half of this k1 obtained earlier. So y naught plus k1 by 2. This value you have to find. That is nothing but a slope of the curve very near to that point. Right? Instead of that point far away, it is made very close to get a good answer. That's the theory behind that. Right? Next, what is K3? That also the slope very near to that point. That's h into at x naught plus h by 2. This coordinate is same. But y coordinate is y naught plus half of k2 by 2. Next, K4 means again that is slope, a point very near to that. That's h into f of x naught plus h, comma y naught plus k3. If you get all these constants, then substitute the formula. That gives the solution for the differential equation at x is equal to x1. x1 is nothing but x naught plus h. This formula is called Runge Kutta method of order 4. Actually, if you take k1 is equal to h into f of x naught y naught, and k2 is equal to h into f of x naught plus h, comma y naught plus this k, that means this coordinate, then this one here replaced by 1 by 2 means it is modified formula itself. That is again modified and is called Runge Kutta method of order 4. Now, when a problem is given, solve by Runge Kutta method means just to get this constant k1, k2, k3, k4 and substitute the formula. That's all. Very simple procedure. Simultaneously, let us see what is Runge Kutta method of order 3. Sometimes if the question is asked, you should know what is the formula for that. In the syllabus, both are mentioned there, Runge Kutta method of order 3 and 4. But first I written this 4 because that is very important. Next, you shall see the another formula also. It is not that much important, but since it is given syllabus, you must know the formula. So, third order Runge Kutta method formula is given by the solution for the differential equation at the point x naught plus h, that is x1, it is given by this, y1 is equal to y naught plus, it is 1 by 2 into, they are writing 1 by 6, but here 1 by 2 into k1 plus 4 times k2 plus k3. Runge Kutta method of order 4 up to k4 is that, but here up to k3 only. So k1 plus 4 times k2 plus k3. For that formula is 1 by 6 into k1 plus 2 times k2 plus k3 plus k4. This is different, where k1 is equal to h into f of x naught comma y naught. I shortly written f naught. F naught means value of f at x is equal to x naught comma y naught, as is in the same formula for k1 as is in RK method of order 4. How to get k2? K2 is h into f of x naught plus h by 2. Instead of writing 1 by 2 into h, I'll write h by 2, comma y naught plus k1 by 2. This is similar to k2 in RK method of order 4. Only change is k3 here. K3 is equal to h into f of x naught plus h, full h here, comma y naught plus 2 times k2 minus k1. That only the change here. Right? This is better than RK method of order 2. That means Euler's modified method. But RK method of order 4 is better than this one also. There we get very fast answer. So these are the formula written. So depending on the formula asked, that means that method asked, you have to answer in the exam. RK method of order 3 means this is the formula and you should know how to get k1, k2, k3. RK method of order 4 means the formula written in the previous slide. Now let us take some examples how to solve the differential equation by both the methods, RK method of order 4 and RK method of order 3. Now this question is using Runge Kutta method of order 4, find an approximate value for y at x is equal to 0.1 for this differential equation. This question also asked in last year's examination, MTech examination, same problem they asked. Here x naught is 0, y naught is 0. H is not given. So when h is not given, you are free to select the value of h. So to minimize the work, if it is x naught, at which point you have to take the solution. If it is very near to that, the full length from that to that point, take it as h. 0 to 0.1, the distance here, 0.1 minus 0 is 0.1 only, small number. So you take h is equal to 0.1 only. So first identify what is x0 is 0, y0 is 0, and choose h is equal to 0.1. In the exam, if it is given, no problem. If it is not given, we should take care which one you take it as h. So here at 0 solution is given, I need the solution at 0.1. So this length is 0.1 minus 0 means 0.1 only. That length you take it as h. Once h is known, identify what is f of x comma y, how the relation is related, variables related by this relation, f of x comma y is equal to 3 times e power x plus 2y. We need the solution for y at x is equal to x naught plus x. That means at 0.1, 0 plus 0.1, 0.1 I need. First step is find k1. K1 is nothing but the slope of that curve, that is h into f of x naught y naught. H is 0.1, x naught is 0, y naught 0, f of 0, 0. But how they're related? It's 0.1 into, the relation is 3 times e power x plus 2 times y. So 3 times e power x naught is 0, 0 plus 2 times y is 0. So this term is 0, e power 0 is 1, 3 into 0.1, 0.3 we get. That is k1. Next get k2. K2 is h into f of the slope very near to this point. That is x naught plus half of h, comma, y naught plus half of this k1. So this will be x naught is 0, h is there 0.1 by 2 means 0.05. K1 is here 0.3, half of that 0.15. So this value we get if simplify. But f of x comma y, how the variables are related? 3 times e power x coordinate plus 2 times y coordinate. So that's 0.1 into 3 times e power x coordinate is 0.05 plus 2 times y coordinate is 0.15. Using calculator simplify, you may see that this value is here 0.3454. Similarly, get k3. K3 is the slope x coordinate is same, but y coordinate is y naught plus half of k2. So this will be changed. Y naught is 0. K2 by 2 means half of this. So you get nearly 0.1724. That is f of x comma y. But f of x comma y, the relation between the variables, this relation 3 times e power x coordinate plus 2 times y coordinate. So if you use it, 0.1 into 3 times e power this value plus 2 times y value. Simple calculation, we may see that this value is 0.3499. Finally, get the value of k4. What is k4? It's h into f of x naught plus h, comma, y naught plus k3. You should know that all these values are nothing but finding the slope of the curve very near points. But in always modified method, at distance 2 points, we are at a 2 distant point, you are finding the slope. That's the difference between these two. That's all. So if you simplify, we get this value is 0.4015. Once all these constants are obtained, use this RK method of order 4 formula. What is that? Y1 is given by y naught plus 1 by 6 into k1 plus 2 times k2 plus k3 plus k4. K1 is known, K2 is known. Substitute all these values here in this formula. Y naught is 0 here. Simplify. On simplification, it gives 0.34868. This is value of y1. y1 means solution at x is equal to 0.1. So y of 0.1 is equal to 0.34868. So this question asked me last exam, I think for 6 marks. So very simple problem. Thing is, only you have to get this correct values of k1, k2, k3, k4. While using calculator, don't make mistake. Get the correct value. That's all. This is one example. One more example, let us see. Applying Runge Kutta method of order 4, find an approximate value for y at x equal to 0.2 and x equal to 0.4. At 2 points you have to get. This is f of xy. So first step is identify x naught, y naught. H is equal to here. You have to take 0.2 because at 0.2 and 0.4 means at 2 points you have to get the solution. The difference is 0.2. So take h is equal to 0.2. First get the solution at this point, 0.2. That you call it as at x1. And another solution at 0.4. That is at x2, x1 plus h is 0.2. At this 2 point you have to get the solution. First step is find k1. Same formula, h into f of x naught, y naught. H is 0.2. f of x naught is 0, y naught is 1, 0.2 into. But here the variable is related by this relation. What is the relation? That is y square minus x square divided by y square plus x square. So it is y square minus x square divided by y square plus x square. So get 0.2. Once k1 is known, you can get k2 also. K2 is same formula, only changes the slope is at a near to the point x naught y naught. That is x naught plus h by 2, comma y naught plus k1 by 2. So 0.2 into, if you simplify this value, we get 0.1. Y naught plus k1 by 2 means we get 1.1. Now, after that, the relation between the variables is y square minus x square divided by y square plus x square. On simplification, we see that this is equal to 0.1967. Similarly, get K3. So no explanation is required here for K3. The same repetition, only changes the value of x and y. On simplification, we see that this value also very near to K2. But you have to note that in RK method of order 4, usually K2 and K3 will be always near because the slopes are at a very near points. So we get almost same answer. But K1 and K4 are different. So what is K4? H into f of x naught plus h, comma y naught plus K3. At this point, you have to get the slope. This is the point where I need the slope. So to get the slope, this is the relation given. And this relation, we get this 0.1891. Now, substituting the formula, what is solution RK method of order 4? It is y naught plus 1 by 6 into k1 plus 2 times k2 plus k3 plus k4. So, on simplification, we see that this answer is 1.196. That is y of point. Now, the question asks you to find the solution at y of 0.2 and y of 0.4. How to get y of 0.4? To find the value of y at 0.4, you choose this value as x naught, this one as y naught. Once again, find k1, k2, k3, k4 using the same relation. Only changes starting point. X naught is 0.2 here, y naught is 1.196. So this is the value. So use under this condition, again get k1, k2, k3, and k4. Right? Same formula, only changes this values because of this x naught is 0.2. This value take. The corresponding value of y, you take it as y naught. Once again, find k1, k2, k3, k4 as the relation defined. The same simplification. At the end, we get all the constants, substitute the formula. So, formula's solution at 0.4 is y1 is equal to y naught plus 1 by 6 into k1 plus 2 times k2 plus k3 plus k4. On simplification, we see that it's 1.3752. That's the solution for this differential equation. So like that, we can solve that any differential equation by RK method of order 4. Similarly, you can solve this type problems using RK method of order 3 also. For 3, what the formula written you have seen. We shall see some examples in the next class. So today, let us stop this because time is over. Okay, thank you.
Thank you, sir.
Thank you, sir.